Alright, welcome back. We're nearly there. We're just going through questionnaires. Now, I think the previous one I said there was a mistake in the answers, but it's just the arrangement of the form of the equation. The answer was correct in both cases. It's just that the arrangement of the form was a little different. Alright, so for S, we've got e to the 2x multiplied by the... Ooh, now this one might confuse you because you might get the sense that there's something to be undone here. But that's definitely not the case. So we've got UV product. So U dash will be equal to the derivative of 2x times e to the u, e to the 2x. So it'll be just 2. I'm being shortcutty, aren't I? That's not good, Jason. That's not good. Okay, V dash will be equal to... Same kind of thing. The derivative of the ln is 1 over 9x plus 4, and the derivative of 9x plus 4 is 9. So it'll be 1 over, it'll be times the derivative, so it'll be 9 over 9x plus 4. Oops. That's very, very naughty, isn't it? Doing a shortcut. I had to wait till the end, didn't I? So the derivative by a product is and so we can put them all together. So u dash is 2 e to the 2x to e to the 2x. V is the ln 9x plus 4 plus V dash is 9 over 9x plus 4 9 over, and finally u. U is e to the 2x. Is there anything common across the algebra? E to the 2x is common, so we can take that out. So we'll get e to the 2x forget your bracket. Now what makes this first term? 2 ln 9x plus 4. And we've got a plus, and we're left with 9 over 9x plus 4. In bracket. So that's your final y dash. Okay, not too bad. Okay, so we're nearly there. T is a quotient, e to the 2x over the ln of x, u v, so u dash is going to be 2 to the derivative, what was already there, v is going to be 1 over x, so y dash, or the derivative of the quotient, will be b squared. So what have we got? U dash is 2 e to x times the ln of x minus u over v, or v dash u. So it's e to the 2x over x and the whole thing is over ln x squared. Okay. So sometimes I see people, they take the x and clear fractions on the numerator, which would be multiplying through, but just on the numerator, e to the 2x can come out. That seems to be a common theme. So we can take e to the 2x out. We need a bracket, so we're going to get 2 ln x and 2 ln x minus 1 over x, all covered by the ln of x squared. And that's your final answer. All right, very good. All right, so we can take these now and use them in some applications, which will be where the end of the course heads. As we head towards the end of the course, there'll be 2 parts that we look for, and that's take word problems and rates and all that funny stuff and make it all work for us. All right, so find the equation of the tangent. So this is actually looking for y equals mx plus b in that form. So we've got to develop our m. Now it's giving us x and y pairs. It's giving us this x and y pairs in A. And it's 0 and 1. So we've got our x and y pairs. So for A, y equals x e to the 2x plus 1. Okay, so let's find the derivative. Now I think in the sheet that I did, I ran this as a pair. But looking at this, I'm not so sure that was correct. So I'm going to backtrack a little bit. Sorry to my group. I'm going to put it as a product pair, but then this will just be a separate independent one. So plus 1 will, on differentiation, plus 1 will just disappear. So we're just looking at u and v. So u dash would be equal to 1, and v dash would be equal to the derivative of 2x is 2 times the derivative of e to the u, which is e to the u, and u itself was 2x. So we've got all of that. So our product differential, and the derivative of 1 is 0, so we don't need to bother with it. So the derivative of product is u dash v plus v dash u, which is now u dash is 1, so I'm not even going to bother. V is e to the 2x. Now if that 1 had an x in it or some other term, things would be different. But it doesn't, so I don't need to worry. Plus v dash is 2e to the 2x, and u is x. I'm going to put the x inside the 2 there. 2x e to the 2x. So that's our y dash. That's our dy dx. Okay, that's our mt. Now we need to find our mt at the point 0, 1. mt at the point 0, 1. So we're going to use function notation and drop in a 0 everywhere there is an x. Okay, so we're going to get e to the 2 times 0 plus 2 times 0 e to the 2 0. So this is e to the 0 is 1, but it doesn't matter because this multiplier here means that these all get zeroed out. So that term's gone. E to the 0 is in fact 1. So the answer is we have a gradient of plus 1 at this point. So plus 1 at that point. Now we've been given an xy pair, so we can now put that together in our yt equation and find b, because we don't know b at this point. So y is 1, m is 1, x is 0, plus b. So therefore, b is equal to 1. So y tangent is equal to x, 1x, because that was our gradient, plus 1, or x plus 1. That's our yt. Okay, very straightforward, I think. Alright, so we'll have a go at part B. Part B says for the same, x is 0. Now look at the difference. X is 0 is being given, but y is it? So how are we going to find y? We need y to put in our tangent line. Y equals mx plus b. So we're going to work x out. So we've got x. We're going to work m out. Y dash for this other thing. But gee whiz, we're going to have to work out y, aren't we? So y equals the ln of x plus 1. Let u equal x plus 1, u dx, y equals the ln of u, dy du, so there's our chain, equal to 1 over u. This one here is just 1, so it's 1 over u. We chain them together, it's just 1 times 1 over u. So y dash is equal to the ln of m, 1 over u, 1 over x plus 1. Alright, so we want to get the gradient at x equals 0 again. So we put in function notation, and everywhere there is that one, we get 1 over 0 plus 1, which is 1 over 1, which is 1. So our gradient is 1 again. Okay. Now, we need to find out y when x is 0. So we use function notation, drop an x in. The ln of 0 plus 1 equals the ln of 1. Now, what is the ln of 1? You might not remember. You might have to do there's my ln function. The ln of 1 is 0. Here it is. On the y-axis. When x is 1, y is 0. You can check it on your calculator if you don't believe me. Come on. Let's have a look. The ln of 1. 1, ln, 0. The graph tells us that anyway. Okay. So that tells us that the y, so we're at the origin. 0, 0. So when we come to do our y equation, we're putting in 0 is equal to 1 times 0. I know it seems bizarre, but that's what you have to do. Okay, plus b. So this is telling us that the intercept b is equal to 0. So our tangent yt is equal to 1x plus 0, which we know translates into yt is equal to x. Tangent at this particular point for this particular function is x. Now, x plus 1 is a shifter. That's the ln of x. The ln of x plus 1 shifts that. Okay, so it'll shift it back so it goes through the origin, like this. This curve that we just found is y equals x. You can check all of that using Wolfie, please. Alright, so that brings us to the end of our tutorial notes and videos. So I hope you're working well, I hope you're getting some help from it, and I'll see you next time.